how's everyone doing? I walked outside for like 10 minutes and already, it looks like I'm burnt. How does this happen? How is this even possible? It's a nice day. It needs 10 degrees cooler. It'd be amazing. But yeah, how's everyone doing? If you have questions, let us know. I am loading up the assignments right now. Who has questions? Who has questions? Who has questions? Anybody? Bueller? Anybody? Anybody about question? Anybody? I'll wait a moment more. A little chill music while we do this. Okay. Garbage bill. Garbage. Get so many emails a day that some of them are just like nothing emails. You know, like a site that has your whatever. Okay. Well, what should we do? We need some people here to figure out what to do. Drop this in the Discord too and say, stream in office hours, swing on by. Oh. Okay. You know what I'm gonna do? I'm gonna email everybody, say like, I'm gonna go instructor gradebook. I'm gonna email people and say like, hey, if you haven't started the quiz, come on by. We go email, like, Brian, you sent me so many emails. I say, I know. Search email by criteria, assignment performance, score is less than a 50, no score. Hey, what's up, Charlie? You want, which Canvas content you want to do? We'll do it. Your choice. Tell me which Canvas content to do and we'll do it. Which Canvas content we gotta do? Which Canvas content we gonna do? Chapter 4, help. Swing by office hours to assignments. See you there. How does the normal probability plot? Yeah, let's do that one. Okay. Hey, Alexis, good to see you here. Let's talk about the normal probability plot. Okay, so I can kind of answer that one without... drop the questions in chat and I'll talk about them. Oh, let's do it. I'm sending this big announcement out. Okay, so Chapter 5, Canvas content. Just drop the questions in here, Charlie, and I'll talk about them right here. Oh, hey. 413, Stat Tool 1, Chapter... or Canvas content. Canvas content, Chapter 5 and 6. Okay. Oh, yeah. Good stuff right there. So with this, a normal probability plot is the plot that shows us the probability it's normal. We talk about this a lot right here. And when you look at a plot that shows us the probability it's normal, it's either going to follow the straight line, which follows the normal, or it's not going to follow the straight line, which does not follow the normal. So you can see when you have a normal probability plot, if the curve is normal, the more it follows the straight line. So the normal probability plot's been added, and it follows the line mostly. So if it follows the line mostly, it's normal. So once again, the normal probability plot needs to follow a line, and the more it follows the line, the more normal it is. What you're actually doing is I'll try to draw it out for us. Draw it out. You're taking basically the values of the normal, and you could use z-scores. Sometimes they use z-scores like -1 to 2 to 3, or -1 to -2 to -3. And then you're taking your observed z-scores. And what you would have right here is, if it lines up, it would make a linear pattern where 0 and 0 mean 1 and 1 meet. It's not like there's a linear relationship. It's just, this is what you expect if it's normal. And this is your observed data over here on the right. And if the points do this, your data follows the normal, because your points, which could be measured here, line up with what is expected on the normal. But if you have skewed data, like skewed to the right data is going to look like this, where all of a sudden your points are a lot higher than where they should be. So that's going to be a right skew data set. Left skew goes the other way. If you have a left skew data set, it's going to look the following. It's going to look like, actually, that's right skew too. That's right skew. Did I just do left skew? Left skew is going to be like this. It's what way, if you think about something pushing it in a direction, it's pushed to that side. That's left skew right there. Did I do that? I did right skew too, I think, first time. And Alexis has a good question here too. So the way a normal probability plot tells us something is normal is if the points follow the straight line or they don't. Outliers can make a weak correlation strong. Here's the answer to all of those. Outliers can do anything to correlation. So some of the things we sometimes draw, especially when we go through the notes here, is this a weak or strong correlation? Someone put weak or strong in the chat, and Alexis will do your question here soon. Is this weak or strong? Chapter 5, part 1. Ooh, Alexis, good questions. Is that weak or strong? Weak or strong? Correlation strength is measured by the tightness of the points. Is that weak or strong? Weak or strong? Remember from today, correlation strength is measured by the tightness of the points. Was that weak or strong? It's very strong. So we went over strength right here in class, and this is super duper strong. So if you add an outlier way, way down here, that is going to make it a lot weaker because it's going to pull it out like that. So that's going to make the relationship weaker. Here's a hint. Outliers are bad for correlation because they can do anything. They can make a strong correlation weak. They can make, oops, I wanted the black one. They can make a weak correlation strong. So you could have something weak down here that looks like a weak correlation, and then it gets stronger because of an outlier. They can make a positive correlation negative. You could have a correlation that goes down like this, so it follows a negative pattern, and you get an outlier up here, and all of a sudden it starts to pull it upwards. So what can outliers do to correlation? Anything. Outliers can strong correlation weak, weak correlation strong, positive correlation negative, negative correlation positive, any of those it can do. A p-value for a correlation which is statistically significant implies something is due to random chance. So p-values range from 0 to 1. P-values go from 0 to 1. 0 means impossible, and you don't really get 0 p-values. 1 means the absolute most likely. Statistically significant, oh, it knows I'm going to write, is less than 0.05. Now, does less than 0.05 sound like likely or unlikely to occur? Does less than 0.05 sound like likely or unlikely to occur? If we say something has a less than 5% chance of occurring, does that sound like likely or unlikely to occur? Because I'll grab the question right here, and then, Alexis, we got one more, then we're doing your question next. Does it sound like likely or unlikely? If something has a less than 5% chance of occurring, does that sound likely or unlikely? Because statistically significant means less than 5% probability. Does that sound likely or unlikely? If it has less than 5%, like it's less than 5% probability of rain today, likely rain, likely not rain. Less than 5%, likely to rain, likely not likely to rain. What do you think? Anyone in the chat? Throw you some points here. We haven't thrown some bots lately. The answer is it would be unlikely. So this would imply that it's unlikely due to random chance. So this is false unless we add in unlikely right there. It might be double. I mean, I'm not saying it is or isn't. I'm not saying it is or isn't, but remember to look at the notes. Does that make sense, Charlie, right there? Double check, like what I was going over with the normal probability plot, where we say when we have a normal probability plot, you look to see if it follows the straight line or doesn't. That's how normal probability plots do it. Like this one is normal because it generally follows the linear pattern, where this one is not so normal because it doesn't follow the linear pattern. And so you can tell the more it follows the linear pattern of the quantiles matching up, the more normal it is. So this was false up there because it's unlikely due to random chance. This is a true statement now because statistically significant means the results were unlikely due to random chance. And the last one right here, which of the following is not a way to describe bivariate? Yeah, if it's good job, Charlie. If it said a high p-value would indicate that what you saw was likely due to random chance. Exactly. If the p-value was high, that would indicate what you saw was likely due to random chance, because p-values tell you the probability of your results due to random chance, given that all is true. So it would tell you your result was likely due to random chance. And for the last one right here, or the other one, so what do you think? Your choices are, this is what is not a way to describe bivariate stuff. Not a way to describe bivariate. Which of these do you think it is? Last one, and then Alexis, we got it going. So which of these is not a way to describe bivariate? Which of these right here is not a way to describe bivariate? So you have univariate and bivariate. Shape. Because univariate is shape, center, spread. And bivariate is strength, direction, form, unusual features. So strength, direction, form, unusual features. A little bit better handwriting over here, where you can see strength, direction, form, unusual features. And that is how we describe bivariate. Univariate is the whole idea of shape, center, spread. But wait, high p-values. Well, high p-values are used for statistical tests. Is the normal probability plot a statistical test? Do you see any p-values on here? Chapter 4 quiz? We might do that next. Well, you guys tell me some questions in it, because we have one from Alexis next. But tell me some questions in it, Abby, and we'll do it. Do you see anything about p-values with the normal probability plot? Yes or no? Do you see anything about p-values on this screen for normal probability plots? Do you see anything about p-values? For normal probability plots, do you see anything about p-values? Once again, look at the screens. Do you see anything about p-values? No. Normal probability plot is just a plot that looks to see if it's normal. When we do p-values, we're probably doing a goodness of fit test, which tells us if the distribution is a good fit, where we would assume that it's normal, and we look for evidence it's not normal. The goodness of fit test uses the p-value. In this instance, since the p-value is higher than 0.05, we do not reject that it's normal. We can see down here another result where the p-value is low, and we see a left-skewed monster man. And since the p-value is low, we would reject that this is normal and have evidence that it's not normal. So because the p-value is low via the goodness of fit test. So make sure you take a note, the goodness of fit test uses the p-value. The normal probability plot is a plot. And there's a little bit of a left skew down here. A little bit of a down there, those points which show up in the normal probability plot. So the normal probability plot is just a visual plot to analyze, does it follow a straight line or not? This one does not. This one does, so this one's more normal. You can also look at the histogram, and you can also do the goodness of fit test where you take a histogram or you take a normal plot and fit it over your distribution. This is a very, very bad fit, but if it was a good fit, you would see it fits very well over it. Ooh, the vital statistics report. There we go. So that'd be a good fit if it looked something like this and you fit the normal curve. That would be a pretty good fit. So with that in mind, let's do Alexis's question. Then we'll do vital statistics report. Thank you everyone for being here. Chapter 5, the Forester. Is this still sending this? Sure. Well, maybe wait. Reload. How's everyone doing today? Everyone having a good day? Chapter 5, part 1. Is it? I see what Alexis said. Is it homework or quiz, Alexis? Is it homework or quiz? It might be on. Let's look at the homework first, because everyone gets the same homework. So if it's on the homework. Yay! Awesome, Alexis. It's on the quiz. Thank you. I was there early, and I was helping employers do it, and I saw a lot of former students, a lot of everybody. I just like being outside. Like, I tell everyone all the time, like, go out, talk to people, you know, say hey to people, ask them if they're doing okay. You know, take a moment and stop. Like, because, you know, people are like, I do it too. Like, I'm like, hey, how you doing? How's your day? But, you know, take a moment and stop, and talk to people and be like, oh, you doing well? Yeah, here we go. We found it. This is one of my favorite problems too, so I'm excited. Yeah, and say hey to me. Like, be like, how you doing, Brian? You said the test looks like the canvas the test looks like the canvas content. Look at the ones I've done and use all your attempts. That's the best way to do it. Look at the ones I've done and use all your attempts. Here we go. Stat 201, Chapter 5, Part 1. Quiz. First time doing these. This semester. Forester measured. We are working with the 68, 95, 99.7 rule. The first thing we have to do right here is find the right graphic. So when you look at these graphics, think about it. You want to make sure the mean is at the center, 10.1. Well, the mean is at the center in these first two. Next, you want to make sure you go up 68, 95, 99.7. So what's the answer? A, B, or C? The mean is not at the center here, so that's wrong. Which one of these has the right order of 68, 95, 99.7, A, B, or C? Just one letter in the chat worth some points. Good guess. It is answer A. We give you some points right there for that. It's 68 right here, 95. I'm gonna give you 5,000, Alexis. Don't worry. Actually, I hit 6,000. So 68, 95. Do you see how it goes? Like the inner area is 68, then 95, 99.7. You want to go with those numbers going in order from the smallest should be in the center. The mean should be here, and this should be one standard deviation, which is standard deviation is going to be 4.9. If this is also correct over here, and you can see the 4.9. How are we doing on this? Does this make sense? That you go 68, 95, 99.7, and then you put the mean at the center and go up standard deviations and down standard deviations. So that's how we draw out the curve right here. So this will be the answer. Now, what's really great about this is we can use this curve to get a lot of the answers below. We're going to screenshot it. There's me. High school Brian. Random appearance from high school Brian. He's everywhere, apparently. No, don't worry. I got, just check the office hours. I got things wrong that I've done these questions so many times. Done them so many times. There's one I got wrong like 3 times this semester already. It's the same question. It's multiple choice. And I'm like, it's because I'm second guessing myself. We all do it. We all do it. The middle 68% of trees is going to be plus or minus 1 standard deviation. The middle 68% of trees is going to be plus or minus. Hey, Benjamin. Yeah, let's do the crowd management. That is second on the list. We'll do another one here, but you perfectly are here. Points for being here. We'll do that one after the next question. I like those initials because they're my initials. So with this right here, I think you can see the answer. The middle 68% is 5.2 to 15. So that gives this one away. 5.2 to 15. Just get the numbers correctly written. Thank you, Benjamin. Awesome. And then we have the, what percentage of trees are below 5.2? This is where what we do is called the inside-outside trick. The inside-outside trick works the following way. If 68% is inside of here, what is total outside? If 68% is inside of there, what is total outside? I want total outside. If 68% is inside of there, what is total outside? Total outside. Total first. If 68% is inside, subtract from 100 to get the remainder on the outside. So you're going to go, because you're going to say 100% minus the middle, because we're asking about, like, this is 68 inside. We are asking what is remaining in the tails. We're going to figure that out. Anyone know? Points in the chat if you know. Take a guess. Don't worry. I'll get it wrong every once in a while. So what is remaining in the tails? If 68, 32, Alexis with some points right there. So we're going to write above here 16 because that's half. We're cutting it in half. And the question wants us to figure out below this point right here. Does that make sense? It says below 5.2. So the answer will be 16. And a lot of these are just like figure out, like draw on your curve and figure out using your drawings. Between 15 and 19.9. Now this is where it gets a little tricky. 15 and 19.9 is not going to be 16 exactly. I'm going to keep the drawing up that we just did. Does everyone see we want this? This is the answer we're looking for. So is that 16? No, because 16 is this. So that's not 16. We need to subtract from it how much? We did data analytics yesterday. Yeah. We got a really good video from yesterday. If you can't find it, Ty, let me know. It'll be here in the live list. Let me know if you can't find it. Yesterday. Good question, Ty. Let me know if you can't find it. So 95 is inside. So we can get 5% outside. 95 inside, 5% outside. Cut it in half for 2.5. So how much is that yellow area worth? Do you know? Does anyone know? For some points in the chat. How much is that yellow area worth? Because we want to take this full yellow area, which is 16 total, and we want to subtract from it this portion here. We want to take this off of it. You got it, Alexis. You're right. Exactly, because you're going to subtract this out of the 16.5 to get 13.5. You're exactly right. Perfect answer. It's 13.5. And that's between a z-score of 1 and 2 or -1 and -2. Last but not least, and actually we got so lucky on this problem, trees over 19.9. What amount of trees are over 19.9? There's 19.9 right there. And we can even delete a lot of our work to only look at the things we need to look at. Well, I mean, our drawing has done it for us. And this is where the practice comes into play. We have questions like this on the test where we give you, you got it. Nice job. And just make sure you do above or below. It can get tricky. We should get 100. But there you go. I hope yours there's many ways this one can go. Nice job, Benjamin, too. Yeah, I like this question a lot. Drop some more chapter 5s in here. Chapter 5 is, not even kidding, it's my favorite chapter probably. A lot of statistics hinges upon the idea of normality and using the normal curve. The central limit theorem comes into play. We'll talk about that stuff later. But really good chapter. Some of my favorite questions. I never get chapter 5 wrong, but when I do, it's not on purpose. Okay, National Vital Statistics Report from Chapter 4 quiz. We'll get that up and going. Draw more questions if you got them. Do outliers make a weak correlation strong? What is it with outliers? What can outliers do to correlation? Who wants to say it in the chat? Outliers can do what to correlation? Awesome, Abby. What can outliers do to correlation? What can outliers do to correlation? I hope that's the right sound effect. It is. What can outliers do to correlation? Can outliers make a weak correlation strong? Can outliers make a strong correlation weak? Can outliers make a correlation positive? Can outliers make a correlation negative? Can outliers make a correlation moderate? What can outliers do to correlation? They can do anything. That's why we don't like them. They can manipulate the correlation. Outliers can do anything. We haven't done that one yet. That one's a tricky one. Outliers can do anything to correlation. That's why we don't like them. That's why we say they can do anything to correlation. So they can totally make your, like they can make the correlation positive or negative. I can show some demos of here in a moment, but outliers can do anything. So if you see outliers can do this correlation, true. Okay, we only have one more question after this, so drop it. They do require special attention, exactly, and sometimes we got to remove them because they might be lies. National Vital Statistics Report looks at all this information right here. Whoa! What kind of monster man are we looking up here? Tell me a 4-letter word. You know what I'm talking about. This is a what monster man? What kind of monster man? We'll get both monster people on the screen. Hey, Chris. Oh, is this Chris from earlier? Is this? Is it? It's. Is it? Is it? I think it is. Hey, let's throw some 5,000 points. Haslam Prepared. Shout outs. If you haven't been Haslam Prepared yet today, swing by Haslam Prepared. I saw so many former students there. And let me say this. If you graduate, which I hope you graduate, please graduate. Well, it took me 5.5 years. I was within that 6-year window if they want to do, you know what I'm saying? But please come back and employ students because you know the students here are awesome. So come back and employ students. Be part of the Haslam family still. Really thankful. Krish, good to see you and good to see everybody. I do these things because I like seeing former students. I mean, it's all part of the experience. I think I might have told you how, like, I saw a student at the mall and they're like, I had you 15 years ago. And I was like, oh gosh, it's been that long. We got some monster people right here. Left skew monster people. A little more bimodality on the monster down here. These are called stacked histograms. Stacked histograms are bivariate displays. They're on here somewhere. There we go. Stacked histograms are a categorical X and quantitative Y. We've got here race, and we have here life expectancy, I believe. Normal, CDF, and PDF. Oh, kind of. That's the cumulative distribution function. The probable, or what is it? PDF is probability density function or so. You kind of use it. It helps us find probabilities. And so here's the thing. On this, and Chris brings up an amazing thing right here. We can't really use it on these curves because they're not normal. Not all data is normal. So not all data can have these functions where we can use it, but we will use them for things like normal data, and we will have that with things like the central limit theorem. So they will come into play. Monster Man, you need a tooth. There we go. Okay. Here we go. Describe the shapes. It's not uniform. Uniform is flat, so that's wrong. Left skew, I think we found it. It's not symmetric. Neither of these are symmetric. Nope, both left skew. So we're good on this. Please tell me if I misclick. How do they differ? There's some more bimodality in, yeah, the range is, no, they both have about the same range. The center for the white distribution is less. Ay, ay, ay. The ranges are similar. So we're between B and C. Okay. So the left skew is going to pull this down more. Oops, wow. I think that's where the, well, it's not going to be that far, but I think, because this is more left skew, and that's going to have more of a, yeah, so the white distribution has a lower, The center for the white distribution is less. I think so. Look carefully at the bar definitions. Where do these plots violate the rules of statistical graphics? Graphics should have the same width for each bar. You see this says under 1 year. So you can't really do this because it should have the same bin width. And I think the last one also. Great job right there, Steven. Yeah, these don't have the same lengths. See, this is a length of 3. This is a length of 4. So they're violating lengths of bins. They should all be the same length. They do appear to cover all possible ages. The intervals are not the same. The vertical axis does not start at 0. Let's look at that. It's hard to tell, but I think it does. That's really mean. Those kind of start at 0. They should have done the same vertical axes. Did they mention that? You should always have the same vertical axes. They don't have the same maximum. Yeah, that's going to be... Yep, they don't have the same maximum. That should be right. Cross your fingers, everyone. I'll throw you 5,000 points if I get something wrong. The answer is I did get something wrong. Is it this one with phones originator? Ooh, I didn't get that one. What did I do? Really? 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 Oh, it's my brother. I'll call him back later. The center for is less. Really? That's tricky. Did I reverse it? I would have thought due to left skew. I want to do this in ChatGPT and say, I want to see if my Pearson's wrong. Well, you have this big mode right here, which is going to be probably about, but they're both left skew. Oh, but you have big outliers. Oh, man. Here's 5,000 points. Brian got something wrong. It's probably due to the large amount of outliers down here. That's really going to pull it. Does that make sense? What impacts the mean a lot? Outliers. And there is a very large amount of outliers on the low side right there. So that's probably doing it right there. That's, I mean, the biggest difference is the bimodality of it. But the low outliers are probably taking it. So I guess it wants you to think there and there. But that's tricky. Well, man, of course they're going to throw a curveball at us, right? A little curveball never hurts. Okay, we only have one more question, I think. One more question. Chapter 4, crowd management. Well, let's go check it out. I can't get questions wrong. Come on, my Pearson. Crowd management. Crowd management. I get it wrong so you don't have to. Crowd management. Where is it? I think it shows 2 distributions. Or is that the one? That's the rock concert attendance. We should definitely do the... We've done that one. Here's the crowd management. There's the age groups. Yeah, it's the crowd crush thing. Yeah, it is. Okay. We're out of questions, so drop the questions if you have them. Because this is the last student-driven question. We don't have any more questions after this. Chapter 4 quiz. Crowd management strategies. Okay. Crowd management strategies looks at crowd crush, and we look at the ages of the individuals who experience this. And here's the ages. So well, it's not a fun data set, but these things do exist. So what do we notice? Well, we have a box plot. And what you're seeing right here is the same data twice. You're seeing that there's some outliers, like people about my age. Start teaching about there. And you have outliers, and then you have the 5-number summary, the min, the Q1, the median, the Q3, which is there. It's not there. The Q3 is the top of the box. And then the max all the way up here, the max. So the max is right here, and that's the same point as is there. And the min is down here, and that's the same point that's over there. And then this is about where the median is at right here, which is towards the center peak of the distribution. So that is the median right there at the center of the curve. The median, which is right in here. There we go. So with that in mind, let's see what they ask. Okay. It is skewed to the right, very slightly skewed to the right, definitely right, with 2 high outliers of 36 and 48. And most victims were between, I think, the younger ages of 14 to 20 or so. So 16 to 24. There we go. What features of the distribution can be seen from the histogram, but not the box plot? Histograms are going to be better at shape, almost like a little test question hints right here. Histograms show you shape better than box plots, which are for the 5-number summary. So box plots can often hide features of histograms, Box plots can often hide the important features that histograms would show, like shape. Box plots don't give you shape really well, histograms do. So there's a second little modal area there that the histogram shows better. The slight increase is going to be what it's showing. Which summary statistic would be chosen to summarize the center? Well, because there's skew. What is it? I want someone to answer in the chat for 5,000 points. Due to the skew, what would we use? Due to the skew and outliers, what would we use? This is a great review question if you don't remember it. You look at shape to determine center and spread respectively. So really good question here. Shape, center, spread. So because it's skewed median, Benjamin, 5,000 points. So you're going to use the median because it is skewed. And if you use median, you're going to use IQR because it is also skewed with outliers. We should get 100. Boom. Boom. No more questions wrong. Well, that's got that one. Is there other questions? We should probably do the fourth grader one. A lot of people get stuck on that one. It has a trick at the end of it. So we could do this one. Drop another question in the chat. Do another question. Do a barrel roll. I don't know how to do a barrel roll. Sorry, Slippy. Some people have no idea what's going on. I don't even know. Do a barrel roll. Canvas content quiz 4 after this. Yeah, sure. Chapter 4. Is it chapter 4, 5, and 6? Is it? Steven, let me know and we'll do that. So here we go. This is the 5-number summary. Make sure you know the values in the 5-number summary. The values in the 5-number summary are the min, the Q1, the median, the Q3, and the max. A really good way to memorize these, chapter 5 and 6. We'll do a version of that coming up next. So if you draw 4 quarters, and then you put 5 lines, and they just label them. The min is the lowest value. The Q1 is after 1 quarter. The median is at the 50th percentile. The Q3 is at the 75th percentile. And the max is when you've gone through all your data. So that is the 5-number summary with things included like the IQR. So now you can go right here and go that this is the min for boys, the Q1 for girls, the median for boys and girls respectively, and the Q3. You're welcome, Benjamin. Great work. And remember, just swing by office hours, drop those questions. I'll do them as fast as I can and explain them. But once again, just hearing these things over and over again, like the 5-number summary is the min, the Q1, the median, the Q3, the max, representing the quartiles in your data going from 25, 50, 75, 100%. Draw your quarters, practice it. I can't tell you enough how, like, if you sit down and write these things out, you remember it better. You create an actual memory by doing it. So just try it. Grab some paper. Draw things out. Draw it out. Which group had the highest score? It's definitely the girls right here. And they had a score of 5.9 with the maximum score. Which group had the greatest range? So now we have to subtract values, and it is once again girls, 2.1 to 5.9, because they have a lower min and higher max. It's going to be a range of 3.8. So the girls right there. Which group had the greatest IQR? So the IQR is Q1 to Q3, and we just go right here and we look at this distance. So it's going to be from here to here, and that's 1.2, and from here to here, that's 1.3. So it's the girls. I didn't even get to say the boys, which is a TV show. No, not the boys, the girls. And which group generally did better? Oh, the boys. There you go. The boys generally did better because their median was higher. That's a good way to measure central tendency. The boys generally did better on the test because the median for the boys is higher. We don't even have means in here. Now it gives us the mean for boys is this, and the mean for girls is this. What is the mean for the overall class? Now, I got lucky. It wants us to round to 1 decimal. This is not how you do it. This is not how you do it. If you average these two numbers, you get 4.35, and that rounds up to 4.4. I lucked out. That is correct. The reason that that's not how you do it is because there's 15 boys. It's like 4.38 or something. Close to. So there's 15 boys and 9 girls. So what you would do is you take the 24 total students and multiply 15 times the boys' score of 4.5 plus the girls' score of 9, because there's 9 girls, times, this is a weighted average right here of 4.2. And so you have to do that to get the exact value. And I wish this question asked to 2 decimals, because then it'd be really mean. Not that I want the question to be mean. So 15 times 4.5, that's that. 9 times 4.2 plus each other. So we're just doing that and divide by 24. And there it is, 4.39 or so. And I hate to say, this is one of the ones people email and say, Brian, I got it right. I know how to average two numbers. But you have to look that there's more boys or more girls. Now, you can go in the direction. You can kind of cheat if you get different versions of the question. Like, I'll show you another version. That's the same version. Is it going to do different numbers for me eventually? Apparently not. Let me try to get real quick. I have to reload apparently the whole thing. And then we're going to do Canvas content. Apparently. 15 boys. Yes. No, it's going to round to 4.6 anyways. I'm trying to get one where the answer is not the obvious, just average the two numbers. Because you can luck out on this one and get an easy version, which makes you wonder how many people are actually doing it and getting it right. Because if half the time it's like, you can get right by just not doing it right. So there's that many boys, that many girls. Okay, good. This one right here is going to be 4.7 because it's going to go towards the boys and not be 4.75. It's going to be 4. And I guess the girls typically did better because the median for girls, the greatest IQR is going to be the girls with an IQR of 1.1. The greatest range is the boys with a range of 3.2. Is that my brother calling again? I'm sorry for Emily. 1 second, everyone. All right, good deal. Making sure everything's fine. So yeah, this one rounds down. Okay, let's do some Canvas content. Chapter 5 and 6. You ready, Steven, right there? Mom, I'm streaming. We talked about that during class. Mom, I'm glad. Student already told me they had fun during class. It's so interesting, like with what I do. Like it's like I tell educators this, that your students have to want to be in class to learn. Like, who's watching right now that agrees, like, to be able to learn, you have to want to be there. And so it's this tough thing about teaching that's like, well, how fun do you make things? Because it's like, you're mixing fun and education, and you can't just give someone a glass of fun. There gotta be some education in here somewhere. A Red Bull. So it's tough because it's like, sometimes we can do a little more fun than education. Sometimes we do a little more education than fun. It's finding the right balance is tough, and still trying to work it out. But yeah. Okay, let me put the. Oh wait, I'm on the wrong video. It's finding that right balance, but the problem is it's not the same for everybody. Some people are going to do a little bit better if there's a little more fun. Some people are going to do a little bit worse if there's a little more fun. There's not this one size fits all education. So if you lean a little more towards fun some days, like I think today was a little bit more fun. And I like that. I like me. So, Canvas content. Chapter 5 and 6. Here we go. Help me out. What do we do when we get this stuff right here? We need to mark our what. You can tell me in the chat. I'll throw you some points. If you get a problem like this, where it says, the test had a mean of this. The test had a standard deviation of this. What do you need to do? What do you do? The test had a mean of this. The test had a standard deviation of this. That's a good answer, Piper. I'll throw you some points for that. Thank you for being here, Piper. You mark your notation. Always, which then you can draw it out. Because watch this. If we draw it out as Piper has suggested. Oh, nice job. Super fast right there, Stephen. If you draw it out, you also see the answer pretty quickly. Because you will see that 70 at the center, if you start going down standard deviations, you'll hit 67, 64, 61, and you would see that your answer is about there-ish, and you could estimate that it's at a z-score of about, as the answer right there is, negative 2.33. You can also solve it by doing observation minus mean over standard deviation, which you probably heard me say 1,000 times, but hey, it's a very famous formula in statistics to find out what a z-score is, which tells us how many standard deviations something is above or below the mean. So we go 63 minus 70 over 3, which is going to be negative 7 over 3, which is negative 2.33. Wait. Oh, wait, Steven, I need you to say, wait a minute, and correct the answer real quick. Let's put it in. It's going to be negative, right? Which means they scored below the mean. Below. Very important. I've had people say, but wait a minute, I got the right answer. And it's like, wait, negative. Very important. Below the mean. So I'll say, do you mind if I just flip the z-score on your test then? They say, no, don't flip the z-score on my test. Unless I did poorly, then flip the z-score on my test. Here we are. What percent of runners do we expect to finish above 31 minutes? Once again, draw it out. Okay. So draw it out is going to work the following way. When we draw this out right here, I do a better line than that. Okay. We draw it out. We put the line down the center. And what's up? It's Jen. Cracking me up. Thank you for the positivity, everyone. Drop a question if you have it. This is our last one working on. And if you don't see your question here, let me know. We're going to put the standard deviations. The standard deviations are 3, which means we go up that amount every time we go up. And we put the mean at the center of the curve. It goes right there. And so now we start going up the standard deviations 28. And we get to 31. And we're looking for the area above this. I should do different colors now so you can see it. We like a nice orange. We're going plus or minus 2 standard deviations. Does anyone know the answer to this already? We're looking to the area above 31. Does anyone know the answer for the area above 31? Does anyone know the answer? What is the answer for above 31? 68, 95. That's at the second standard deviation right there. 1, 2, 3 standard deviations. You go negative 2, positive 2. What's the answer? Who knows? We're looking for this area right here. What is that area? Well, it's 100 minus. Yep, you got it, Stephen. Great work. And then you cut that in half because we 5 divided by 2 equals 2.5. And then you can check your work by making sure it adds up. And you go purple. Whee, and you get up to 100. So it is 2.5 because it's the area above 31. Try drawing these little drawings. It really helps out. If correlation is close to 0, it implies no relationship. Correlation only measures what strength? We talked about this in class. Good review. Correlation only measures the what strength. It's kind of implied here. A has a good correlation. B does not, even though it's strong. Correlation only measures the what strength. We get into more detail, especially later on. But correlation is only meant to measure the what strength. Probably literally going to say in the notes here in a second. I mean, that has a decent correlation. Correlation is only measuring, like it wouldn't really work right here. Correlation only measures the what strength. Correlation is only used to measure the what strength. Correlation is only really used to measure linear strength. Linear. So you can have relationships that look like the following. Sure, ask away, Logan. Drop it in the chat. So you can have things that have a correlation close to 0 that are very strong. So if correlation is close to 0 implies there's no relationship, that's false. Because you can have things that have strong relationships that don't have a correlation because it only measures linear. To create a scatter plot, both variables must be quantitative. That's what we saw. A p-value which is statistically significant implies that the correlation is due to random chance. That is very false. We were talking about that earlier. A low p-value is statistically significant, and that would imply it's unlikely due to random chance because the probability is low. P-values tell us how likely something is by random chance. So if the p-value is low, or than 0.05, it's said to be statistically significant, and thus a low p-value would imply something is unlikely due to random chance. So this is false. We should get everything right. Should. I do make mistakes every once in a while. You drop the question in the chat. We'll do another version. This one right here. Jerry is 3.5 standard deviations below the mean. We did that one before. This one is observation minus mean over standard deviation. You observe a candy box being this. I haven't solved this one yet by drawing it out. We did it in class too, but I'll draw it out here. Once again, please practice your notation. If your box of candy weighs this much, That is what you observe. If the company tells you this is the mean, that's the mean candy weight. If they say it's the standard deviation, this is the standard deviation. So observation minus mean over standard deviation is z-score. And we do observation of 486 minus 479. I knew it. I can tell when I'm about to draw there. And 21.6. So it's going to be like 0.36 or something. 486 minus 479, 21.6. There we go. Was that right? No, something's off. Yes, look at that. It's off by a factor of 10. I was like, that seems way too small. 486 minus 479 divided by 21.6. And there it is right there. There we go. 2 decimals. To create a scatter plot, both variables must be quantitative. A strong relationship can have a correlation close to 0. True. And which the following is a bivariate display of quantitative data. That is a scatter plot. When I entered the box plot for demand on rain days and no days, there are 2 different numbers where the median is. I think what you're seeing is you're seeing the mean and the median. So I'll show it over here. I think we might still have it up. That's analysis. All right, 1 second. 1 second. Daniel X3. 2 seconds. Okay. I think we're good now. Okay. Okay, I'm going to do something here which is not what you should be doing. I'm just going to quickly make a graphic. So I'm just quickly making a graphic. Yeah, here, I'll show you right here. Did you I'm assuming you probably used yesterday's office hours video, and I hope it helped. Stat tool 1, data analytics 4. Is it data analytics 4? 3. Side by side box plots. Someone came by while I was teaching. I wanted to say hello, but maybe I should have. Maybe they were gonna like. I told them like, come by and do a guest appearance, and they're like, I'll come by, and then they're like, oh, Brian's teaching. So that little X right there. So when you put in the like, watch out putting it right over it. But now when we add in the data labels, you will see they appear right there. And what you could do is if they're appearing with all these crazy decimals, you could probably take these and round them down. Really? Really? Oh, because it's, I know why. It's because of that. And now, look at that. Beautiful. And now we can go right here. And now we can go to insert and go here and do this. And now we go to add chart element, data labels, and do to the right. And let's try right here. Okay. I really think you should make this lighter. I don't know why they don't do this already. Fill, fill, and then fill, fill. Easier to see. You can click the numbers and increase the font size. Where's the numbers? Numbers. Boop, 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 boop. Yeah, so that little X right there is the mean. And these have some low skew to them, left skew. And then just make this all nice and pretty. I wish you could move. I don't know why it won't let you move the boxes a little bit more. Like, why doesn't it? There might be a way to create a bigger separation. Is there not? Width. Huh? That's not doing it. There has to be a way. Join type. Bevel. No, it's... Wait, it should be updating these. That's not got it. Nope. Oh, look, show mean. Well, that's... Let me see if I can get this. Transparency. Wait, why is it not changing it? Color. What's changing? Oh, wait, I think I just messed it up. I did. I did. Okay, I was changing things. I didn't even know it. That's the fill. That's not going to do what I want to do. Why can I not? I want to move. I don't know why you cannot move this box plot a little bit over to the left. Any thoughts on this? Any questions or thoughts? Because I really just want, like, I don't know why you can't just move it. Like, why do you not use this whole area more? Gap width. Ooh. See, why can't you do numbers on the outside? That was weird. Whoa. Is that what happens if I do this? That's ridiculous. Okay. Oh, because I'm doing it for the one and not the other. That's... So you could do that. Just turn that off. I'm just checking out what these do. Click every button. Hello. Don't do what I'm doing. Don't do what I'm doing. It's ridiculous. All I want is a separation more between them. Which apparently you can't do. Such a bummer. Let's... Unless... No... I mean, that's not so bad. And you could remove out the middle number then. Or now we can't get the middle number anymore, can we? They take away that option from us? You can just delete it by clicking it, I think. If I could just click that number. Where'd I find it? Actually, this isn't so bad. I mean, aside from the crazy thing that I put on it, I literally had that. Not text options. Well. Legend. So many. Oh my gosh. Oh, because you got to click this. Wow. Number. There's so many things you can do. Oh my gosh. Whoa. Oh, so you can make one left and can make one right. Okay. Okay, so you can make one left and one right. So if we click these, and then we go to here. Oh my gosh. What do you think, Logan? After all that, what do you think? Take a look at that. All that work. To what you have to do is you have to click the numbers and then go here and choose specifically for these to do that. Then you can do decimals and stuff to it. So you could also change work of art. Do some craziness on. There we go. Don't do that. Well, I think that's really good. And then we found the thing to bring it back. You have to click the numbers. What you click is what you change. So you have to click the thing you want to change. I mean, who would have thought? What a wonderful thing. Yeah, we're not asking you to, you don't have to include, I'm doing Command Y or Control Y to redo. But yeah, make sure you put the proper things on here by going to the design and going, you can go to quick layout and stuff. It's changing my layouts, but you can add chart elements with axis titles and stuff. But yeah, any other last questions right here? This might be towards the end. Good hour of office hours. Data Analytics 3. Sub-asset box plots. We figured it out. We figured out how to do the left and the right. Oh, this is the gradient I think I did. I think I did the gradient around it maybe. But well, that's got it. I might swing by to see if I can see what EA's doing. And Jonah, mountain biker here at UT, might be there. So we'll be here, I guess, next week. But if you have questions, let us know. We got a lot of help videos out there. We did a lot of the hardest questions today. Till then, let me 35,000 points. Bye for now, everyone. Bye. Wait. How do I turn an area under a curve into a percentile? Which one are you doing, Steven? You can do some pull-ups, Logan? I need to do some. Try to Shoulders. I feel sore and I haven't done anything. What have I done to myself? Which one are you working on, Steven? Are you working on like a one of the chapter 5 canvas contents? How do I turn an area under a curve into a percent? Well, that's what the area. So the percentile means area to the left. Davis Dills. He's Jeff Nipper's caliber guy. Oh, I should check that out. What does it say for your question? Let me find it. I'll find that one. We'll end on that one. What does your question say? I'll check out that guy. Davis. What's his name again? Davis Dilly. I used to. Oh, yeah. Oh, no, we didn't do all this. We're going to get a bad grade, but that's fine. You too, Logan. Have a great weekend. What does yours say? Some quiz. Let's keep doing questions. Drop the star of the question. There's things on correlations. I'm not even getting any of the really, really tough ones. Why don't I get the tough ones? Is it this one? Is it this one right here, Steven? We haven't done this one yet. Let me know if it's this one. Or if it's different. All right, let's do it. Here we go. 57. I was having fun with, like, I like just, like, trying crazy things with graphics. I like graphics. Canvas content. This is in 992 article. Okay. So whenever you get a graphic like this, the first thing you want to do is start labeling it. Everyone hear that? The first thing you want to do with a graphic like this is start labeling it. So what we see right here is these numbers are associated right here. So we can see where these numbers are associated. It's telling us that 13% of the area is the area on the outside. So this area right here, this 13%, is over these two portions. So how much is in this area right here? So, Stephen, how much is in for 5,000 points? How much is in this area right here? How much is in this area? Any thoughts? What do you think? Because remember, it's 13% total. So how much is in that area? How much is... You're right. This area is 6.5. This is also 6.5. The middle area is 87. I know you're like, wait, 68, 95, but 68 is between here, 95 is between here. It's giving us a picture with different areas than we usually get with the 68, 95, 99.7. This is 87 in the middle, because if 13% is on the outside, 87 is in the middle. So now that we've labeled this graphic, let's see what they want us to do. They want us to figure out the area higher than, you're never going to be able to read that. They want us to figure out the area higher than 99.26. Wait, 99.26 is right here. Because that's where 99.26 is, you can kind of tell. What is the amount of area higher than 99.26? What is the amount of area higher than 99.26? Do you see it? With a properly labeled graphic, because it gave us the information. Yeah, no, it just wants the area. This would be the 93rd.5th percentile. Yeah, and then the area above here, you're like, oh, that's it? That's it? Yeah, 6.5. We should only get one question correct now. There we go. What's the strongest negative correlation? Negative that, because it's negative, and it's closer to -1. I think. I don't see anything closer to -1. We should get a 4. A 4. We got a 4. Yes. Great job, Steven. Thank you for asking. Please ask at any time. If I see it before I end the stream, I'll do it. So sometimes I just try to get some fresh air and everything, and then I got my stats bonus cards. I might have to bring all these today. I gotta watch out. I'm gonna run out of these after the semester. But with that, bye from everyone. Bye.